definition of a parallelogram was that it was a quadrilateral that had two pairs of opposite sides being parallel. So that was really all we knew about a parallelogram, was that the top and the bottom would be parallel, the left and the right will be parallel. Today we're going to learn additional properties about those shapes, okay? Not just the definition. So this one says find each angle measure in the parallelogram below. So if we have parallel lines, what type of angles are A and 60? Are they corresponding, alternate interior, alternate exterior, same side interior, or same side exterior? Marquise? Good. These would be same side interior angles, which we know, based on the theorem, are supplementary when you have parallel lines. What would A have to be? No? 120. 180 minus 60 is 120. Now, we also know that this line is parallel to this line. So these two angles, A and B, these would also be same side interior, which are supplementary. So 180 minus 120 will get me 60. And similarly, these two would also be same side interior. Remember, in a trapezoid, you don't have all four, but in a parallelogram, you would, because you have two pairs of parallel sides, which would make this 120. What do you notice about the relationships of the angles, besides the supplementary part? Joseph?
They look opposite of each other.
Yes. The ones that are opposite of one another, those are actually giving you the same exact measurement. Okay, that's one of our properties of a parallelogram that we're going to learn below. So consecutive angles of a polygon are angles that share a side. Think of consecutive numbers, 1, 2, 3, 4, they go in order. Consecutive sides are going to go in order and be right next to each other. So consecutive angles would be the same thing, they're angles that are sharing a side. So you have consecutive sides, and then you have consecutive angles. So an example of consecutive angles from above, or from this picture, would be like angle J and angle K. Angle K and angle L, L and M, and J. Who can give me an example of non-consecutive angles? Maddie?
Angle J.
Say again?
Angle J.
Okay.
Angle L.
Angle L. These would actually be consecutive because they're sharing a side. These would be consecutive because they share a side. So the non-consecutive would really be opposite. Okay. And you can think of non-consecutive as being opposite across the quadrilateral. So theorem 6.1, and we don't really do any proofs with these theorems. You just apply them to problems and solve for x or solve for side lengths. So theorem 6.1 says that the opposite sides of a parallelogram are congruent. And you probably realized this when you did some of your coordinate proofs. You realized that like you got the same distance for the top and bottom and the same distance for the left and right. So if you have a parallelogram, you'll know that both pairs of opposite sides are congruent, not in those markings. Theorem 6.2 tells us that opposite angles of a parallelogram are also congruent. So angle A would be congruent to angle C, the whole angle A. Now sometimes they will cut it like in bisect the angle or something. You want to make sure that you're talking about the entire angle. So even if you had to call it BAD to get that whole angle. And then angle B, put different markings, is congruent to D. They're not all the same unless it's a rectangle or a square. And the diagonals of a parallelogram bisect each other. Who remembers what it means to bisect? Bisect. It's segment bisector, angle bisector. Anything to bisect. Noah? Good. Cut in half. Or cut into two congruent parts. In this case, it will be segments. So we want to draw in the diagonals because right now they're not there. So just do your best to sketch in. two diagonals connecting the opposite vertices. Now, when they bisect each other, it means they cut each other in half. So one of them, like US, would be cutting RT in half. So we put a mark on, let's call this middle point, I don't know, M. So RM would be congruent to MT, and UM would be congruent to MS, which you want to put two markings. So use different markings. Now, whenever we get to some of the other shapes, you'll find out that the diagonals are congruent and bisected, which means you could put the same marking. But for a parallelogram, we don't know that those are the same numbers. Okay? You do want to memorize these theorems. That'll help you to solve all of the algebra problems. I do have a graphic organizer I give at the end, towards the end of chapter 6, where we'll put all the properties together, so you have like one study sheet to kind of look off of. Because we're also going to learn properties of trapezoids, properties of rectangles, squares, rhombuses, all that things. So in this one, and I should tell you that this shape, anytime you see it, means parallelogram. Sometimes, depending on the font that's used, it will look like a rectangle, but anytime you see a four-sided shape like that, we're going to let it be a parallelogram, PQRS. Find the value of x and the length of QR and PS. So in a parallelogram, we know that it obviously has parallel sides, but from the theorem above, we also know that the opposite sides are congruent. So opposite sides of a parallelogram are congruent, which means that QR is congruent to PS. That would be using theorem 6.1. Not that we're doing a proof, but we can then say if they're congruent, then they must be equal. No, you don't have to show all this work, but this is, you know, what we would normally put in a proof. Then you can use substitution to sub in the values that we have for our algebraic expressions. And then just solve for x. What do we got? Go. X equals 18. Subtract 2x, add 15. X equals 18. So that's one of my answers. Actually, probably should have a line for that over here. And I also want you to find QR and PS, which should be the same number if done correctly. So take that 18 and plug it back in. Joseph?
39.
Okay, we should be getting 39 for each of them. Technically, that's 39 units, because they didn't tell us if it was inches or feet or whatever, but sometimes they will. Don't put degrees on angles. All right, the next one we have another parallelogram. This time they do give us angle measurements. So based on theorem 6.2, we know that opposite angles of a parallelogram are also congruent. So we would know that angle D has to be congruent to angle B. Technically also angle A would be congruent to angle C. So if the angles are congruent, then they're equal in measurement, so we can set those equal. Go ahead and solve and plug it back in. They want you to find the measures of all the angles, A, B, C, and D. So see if you can do that. We're not done, but I'm going to pass out the homework while you're finishing up that one so that I don't get rushed for time at the end. We do have one harder one on the back where we'll have to solve using Algebra 1 skills, solving by substitution, a system of equations, which we should all know how to do. We all successfully completed Algebra 1 as a prerequisite for this course, but I will refresh your memory. Sometimes if you ever lose these worksheets, they're on your classroom, so you can always do it on the computer if you like. All right, who can tell me what they got for x? Marquise?
X equals 60.
Good. Which makes, none of the angles will be 60. What was the measure of angle B and D then? Maddie?
75.
75. Just by plugging that 60 back in. How do we find out what, so this is 75, this is 75. How do we find out what the measures of A and C are? Angles A and C. Joseph?
Set A supplementary and angle B.
Good. These two are supplementary and these two are supplementary because they're same side interior. So you just have to subtract 180 minus 75 and we'll get 105. If you wanted to check your work, you could use quad sum and make sure that these all add up to how many degrees? 360. Remember, no, quad sum is 360. All right, on the back we have our diagonals bisecting each other. Number 3, we're going to set up the equation. We're not going to solve it because you should know how to solve it. Number 4 is the harder solving one, so we're going to make sure we get to that. So this one does tell us that we have a parallelogram. Remember, that's what that symbol means. And one of the theorems on the front, 6.3, can't remember the numbers ever. You don't need to know the numbers. The diagonals of a parallelogram bisect each other. So, let's put a point in the middle, call it O. If they bisect each other, that means that we would know KO is congruent to ON. And we would know MO is congruent to OF. If they're congruent, then they're also equal in length. So you would just set up an equation setting 6y plus 1 equal to 4y plus 9. Don't solve it. We don't have time to solve it, but you know how to solve. And you would also set 2x minus 5 equal to x plus 7. And then you would solve this, but we're going to skip that right now because you should be able to solve a single variable equation. We want to look at the harder one, which is number 4. Number 4 looks almost identical, a little slanted picture. Same thing. If this is a parallelogram and we're given the diagonals, we know that diagonals bisect each other. So we would mark that KA is congruent to AN and NA is congruent to AL. Okay, write two equations setting those equal. So for example, 2x plus 5, that's KA, equals AM, 5y. Okay, see how this is harder? We have two variables. Do the other one. Now for this one, instead of saying 7y minus 16 equals x, I would probably write it as x equals. It will make it easier for you personally. So x equals 7y minus 16. So this is a system of equations. In Algebra 1, you learned 3 ways to solve these. Graphing, substitution, and elimination. You're going to want to use substitution for these. To use substitution, you have to get one variable by itself, which it is, x is alone. You take what's on the other side, and you substitute this whole expression, using parentheses, in for x in the other equation. So this will become 2 times 7y minus 16 plus 5 equals 5y. Solving by substitution. We did see this in one of our other units this year. And all I have to do is solve. Distribute, electrolyte terms. And just really later time. Should get y equals 3. Of course, to get the value of x, you take the value for y and you sub it back into the x equation. You should get 21 minus 16 which will get me 5. If you want, you could take the time to plug those values back in and make sure that they do come out to be the same exact number, but they didn't ask us to find the lengths of the segments. Okay, the last theorem then basically tells us If 3 or more parallel lines are cut off into congruent segments, so you have 3 parallel lines, you could have more of them, but you have at least 3, and they are cut into congruent segments by one transversal, then what this theorem tells us that any other transversal you draw in will also be cut into congruent segments. They won't necessarily be congruent to the first ones, but because these are equally spaced, showing that this has to be equal to this, then any line you draw in would have to have congruent pieces as well. Like I could draw another one in, like this, and those would have to be the same as those. They will have different markings though. So if AC is congruent to CE, then BD would be congruent to DF. And there's one quick problem that does that. You can see that these are all marked with 2s, which show you that they're congruent. Therefore, these would all have to be congruent. If one of them is 2.5, all the others are 2.5. They ask us to find how long segment EH is, which is this whole thing, which would be 2.5 plus 2.5 plus 2.5, or 2.5 times 3. So 5 plus 2.5 would get me 7.5. The closer just have you kind of filling in the blanks with the definition and the theorems we learned today. So we don't have time to do that because the bell's about to ring, but you guys could be able to do that from the front of your notes.